What's going on, everybody? Today's video, we're back to the N64 Programming Primer Series. This is part 2 of us covering the lights demo. So without further ado, let's just dive into the code. Here we go. So here we have teapot.c, which again is our main C source code file, and we have two supporting files that we have here, teapot.try.h and teapot.vtx.h. So I'm going to run through this quickly. I'm not going to be explaining every single line of code, but I will try to explain as much as I can and speed things along here. So usually you have some include files, different commands that are needed to be run in this main source code file. You have to have the different include commands to provide those functions and have them so that they are accessible in your main C source code file. So now a term that you're going to hear a lot when you're dealing with N64 code, that is the term thread or threads. So threads are essentially a way for the N64 system to assign priority levels to different processes or functions that need to be executed and provide data at designated moments in time as the game is run. So technically you could have your entire game and your block of code be, all executed as one, but if you break it up into these little sub-programs, which they call threads, it makes it a lot more efficient. And each of these threads, they're assigned a dedicated area of memory that they call a stack. And so if you're familiar with the basics of C programming, a stack is just a dedicated area of memory for storing like variable data. And so each one of these little sub-programs that they call a thread, each one of them has a dedicated stack memory. So as you can see here from lines 56 through to 63, so we have an idle thread, we also have the main thread and an arm-on thread. So the idle thread, I've made some comments here, the idle thread must exist at all times so it can be executed when all higher priority threads become inactive. So the idle thread is pretty much there just to allow the system to run properly. Now, of course, the main thread is our game, and we also have a arm-on thread, which is pretty much used specifically for the debugger. So you don't really have to worry about that too much. So you essentially have all these threads competing for the CPU in order to process all the information that each thread requires. And it communicates back and forth between threads and the N64 system using what they call a message queue. And so you have all these little communication messages bouncing back and forth between threads and the processors in order to optimize and have everything running so that all the data is available when it needs to be. We also have a structure here that's specifically for the signal processor. I'm not going to get into that right now. And we also have some variables being declared here for some of the processes that we're going to be running. But the main thing I want to talk about right now is this function here that's called boot. Boot, boot, boot. And so all of this code here as we move down right to the end of this function. So if you guys remember when we were talking about the spec file back in my previous video, there was a specific line in the spec file that referenced a boot command. And that's essentially this function right here, which gets called when the N64 is turned on and activated. All the commands and variables that get declared in here is essentially run when you boot up the system. So one thing I highly recommend that everyone does while you're working on your code is to have your web browser open to the N64 online manuals. Here we have the Nintendo 64 Function Reference Manual, and this is accessible from the ultra64.ca website. I'll provide this link in the description for you guys to reference. And again, I just highly recommend that you keep this minimized in the background while you're working on your code, allowing you to just go here and select the search all, and then you have every N64 function here to reference. And while you have your web browser open, you can simply press Control F on your keyboard and then insert any of the commands. So by hitting enter, it gives you a brief summary of what that function does. So we have performs hardware and software initialization procedures. And if you go ahead and click on that, it'll give a detailed explanation and also provide all of the parameters that this function requires. So I just highly recommend you keep that minimized on your screen while you're working with code. So these two commands create and start the idle thread, and from there you can see that an idle function gets called once that is completed, which is this function right here. So this is the next function that gets executed in our game after the boot command. And in here we initialize some of the hardware, that being the video, and as well as the PI manager for accessing the ROM memory. From there we create and start the Armand thread, which is used for debugging, as I mentioned earlier. And that will trigger this function here for debugging purposes to be running in the background. After that has been started, we go and create and start the game thread, which is the main thread. And that will trigger our main proc function, which is the next function in our code. Now regarding threads, one thing I just want to clarify and make sure you guys understand. You should be looking at a thread as something separate that runs as part of the N64 operating system. So it's a small sub-program that's just part of the N64 operating system, and that gets put into your ROM and is processed and run as part of your game in main memory in the RDRAM. Now that happens behind the scenes. You're going to have instances where you're going to also have audio commands that have to get executed for either setting up the audio hardware or specific functions for running all of the graphics and all the different commands that are associated with that. And so by using these little sub-programs that they call threads, that allows the N64 operating system to take control of when and where these functions are executed. And that again is based on the priority levels that are assigned. And those priority levels can change at different points throughout the game when certain functions and commands are executed. Now I'm going to bring in this graphic. This is part of the Nintendo 64 introductory manual. So there's a really great graphic here. So again, just remember that each thread is a little sub-program that is running as part of the N64 operating system, and that's sort of running in the background as part of your game and is running in the main memory in RDRAM. So it's a small little sub-program that will determine which thread is next in line to then run and process that function that's associated with that thread. You also have how threads will then go into a waiting mode or a wait state, where it will wait for one of the other threads to complete a specific task, where then a piece of information is ready for this thread to then resume. And so you're constantly having these threads bouncing back and forth between executions. So as you can see here, the flow of how the game is run. So you're having thread A to thread B to thread C to back to thread B, and then straight over to thread D, bypassing thread C. So there's all this flow happening here, and that is determined by the message formats that are being created by each thread and specific commands relating to thread priorities. So again, I think it's important that you realize that each thread is a separate little sub-program that's running within your game, and then that thread controls which function it will run and when it will run it. And again, that's part of the N64 operating system. So that wraps up today's video, guys. Thanks again for watching. Hit the like and subscribe if you can. I do appreciate it. Take it easy. Ciao.